Okay, so in this video, I'm going to cover Q12 and Q13. So for Q12, we just want to calculate the relationship between frequency, angular frequency, and period. So if you remember, uh, basically the period t is equals to 1 over the frequency. And we know that the angular frequency omega is equals to 2 pi f, or that the frequency f is equals to omega divided by 2 pi. So we have those three equations, okay? And then the problem just asks us to basically convert some values here in this particular table. So if you plug in the values on those equations, you basically get the results. Like for the 6 gigahertz that we have a frequency. If you want to convert that to radians, we just multiply those 6 gigahertz to 2 pi, and that's equals to 37.7 gigaradians per second. And if you want to calculate like the period, you just take 1 over that 60 gigahertz, which corresponds to 166.67 picoseconds. Okay, but the steps to basically solve this problem, it's basically the same. So from 8 gigahertz to frequency, you just have to divide by 2 pi. Once you know the frequency here, just take 1 over that, and then you calculate the period. So it's pretty straightforward. It's just to remember you what's the difference between frequency, angular frequency, and period. Okay, and then remember that frequency, it's how many oscillations you have per second. So hertz here means per second, right? And oscillations per second. And the angular frequency means radians per second. So how many full cycles, like full rotations you have per second, okay? Full radians when you cover like an entire 360 degrees, right? And the period here is just like the length in time of one single oscillation. So how long it takes from 1 0 crossing. So if you look at the like a sine wave here, right? So how long does it take to go from this point to that point here? So that's your period. Okay. Now for question 13, we have the relationship between peak, peak to peak, and RMS voltage. So if we know that the sinusoidal is represented by the input signal is represented by Vs, so Vm sine of omega t. Okay, we know that for a sine wave, the peak voltage or the amplitude is going to be Vm. The peak to peak voltage, if we look at the sine wave here, is the difference between this point here and this point there. So that's the peak to peak voltage, which for a sinusoid, it's basically the same as 2 times Vm, right? And then for the RMS voltage, we just calculate the RMS for a sinusoid. It's equals to Vm divided by square root of 2. Okay, so like for the first case here where we have 10 volts, the peak to peak voltage would be 2 times that, so it's 20 volts, right? And the RMS value would be 10 divided by square root of 2, so it's the same as 7.07 volts. Okay, and you could apply the same thing here. So if you know the peak to peak here, it's 15.2 volts. You just have to divide that by 2 to get the peak voltage, which is 7.6, right? Now, if you want to calculate the RMS, then you have that 7.6 and divide by square root of 2, which is 5.37. And you can apply that for the following, for the other 3 rows here. So it's again pretty straightforward, right? So just remember the relationship between those 3 quantities, okay? So that's it for this video.